New icon, and I'll select Part MMGS as my template and click OK. I must first create a sketch in order to create the Revolve feature, and so I'll right-click on the front plane from the feature tree and click Sketch. This sketch profile will be created using a series of lines. I'll enable the Line tool, and I'll begin by drawing a vertical line starting at the origin. This will serve as the axis of revolution for the Revolve feature. I'll continue sketch lines to create the outer profile of the piston head. Before I begin adding dimensions to the sketch, I want to be sure that I can dimension the piston according to its diameter value rather than the radius. To do this, I'll change this vertical sketch line on the left to a construction line. I'll click on the line, then select Construction Geometry from the Context toolbar. Even though this construction line changes the sketch profile from closed loop to open, the profile can still be revolved using the construction line as the axis of revolution. In many cases, the revolved profile won't be attached to this construction line, which can create a custom-shaped hole going through the middle of the Revolve feature. Now, I'll add a few dimensions to fully define the sketch. First, I'll add the dimension that defines the piston head's diameter value. I'll enable the Smart Dimension tool, then select the center line and the blue line on the right. Now, when I hover the cursor above the sketch, you can see a regular dimension appears between these two lines. However, if I move the cursor to the left, on the other side of the center line, it switches to the diameter value. SOLIDWORKS automatically recognizes that this dimension can be used to create a diameter value. I'll place the dimension here and give it a value of 150 millimeters. I'll add a couple more sketch relations and dimensions to finish defining the sketch. The small segments at the end should be equal so that the wall thickness of the piston is constant. I'll dimension one of these segments to be 20 millimeters. And I'll dimension the total height of the piston to be 125 millimeters. Now my sketch is fully defined, and I can create the Revolve feature using this sketch. The Revolve feature can either be found under the Insert, Boss Base menu, or I can activate it by clicking on the Features tab of the Command Manager and selecting Revolved Boss Base. When I click on it, SOLIDWORKS prompts me that this sketch is currently open. This is because I changed the short vertical line on the left to be construction geometry. To create non-thin revolve geometry, the sketch will need to be closed, so I'll click Yes to automatically close the sketch. In the Revolve Property Manager, the construction line is automatically selected as the axis of revolution. Also, because the sketch profile was closed when I clicked Yes, the preview of the Revolve is automatically generated. If there were other contours I wanted to include in the Revolve, I could continue selecting them. I only have one sketch profile, so I'll move on to the options for Direction 1. Here, I can specify a number of end conditions that define the geometry. To create a fully revolved feature, I'll set this end condition to blind and set the angle value to 360 degrees. Now, when I click the green check, the Revolve is created. Now the piston head can have a cut created along the outer face of the piston. However, before I move on to the next video to create the cut, I want to verify that the piston head is 150 millimeters in diameter. To do this, I could use the Measure tool, but there is a shortcut. I can simply click on the top or bottom cylindrical edge of the piston, and the diameter value appears in the status bar below. I can also click on the outer cylindrical face of the piston to achieve the same result, and you'll notice the diameter matches the value I expected.